Hey guys, so for today's legal question is maximize the minimum power city. So the legal questions are getting harsh during this day, and now the people online is getting dropped from around like 25k to now 1k because of we are facing the hard question the day before yesterday, and then now it's a hard question again. Here we go. So we are given a zero index initial array station of a length of n. So and then where the station of I represent the number of power station in the I city. So each power station can provide power to every city in the first range. So in other words, if the range is denoted by R, so then the power station at the city I can call provide to all the city J. So I minus J is less than or equal to R. Okay, just ignore this like mumble jumble keywords. This is making the question to more difficult and make you confused. So we're gonna skip to the later part. So the power of a city is the total number of the power station is being provided power from. So the government have sanctioned the building cave to more power station, each of which can be built in any city, have the same reach as the existing one. So given the two integer R and K, we should need to return the maximum possible minimum power of a city if the additional power station are built optimally. So note is that we can build the K power station in multiple city. So that means like we have two stations that can build in any city, or if we want to spread like one in each city, that's also okay. To do the sum explanation, I have prepared the sum notes. So let's go for example 1. So in example 1, we have been explaining that we have a station in 5 cities. That means like, let's consider this is one city. Let's say this is New York. This is Boston, or this is whatever the city. So let's say the first city have a one power station, the second is a two, the third have a four power station, and the fourth have a five power station. So according to the given parameter, which is R, what we can do is by using the R, we can spread our power station to our nearest city, which is 2, mean left and right. So if it is 3, that will be like, if it is 3, that will be like this. So let's say we have like 3 artifact city. So this is example. And then, okay, now since we only have a parameter is 2, what we're going to do is very straightforward. We're going to check how many powers are we spreading across the city. Since the R is 2, so we're going to calculate the possible number. So let's call it as here. So how do I get the 3? Since we don't have no values on the left side of the 1, so 1 plus 2 is 3. And then for the first one index of array, we combine the 1, 2, and 4 because we gonna move this to here. So 1, 2, and 4 combination is 7. Next is index 2, 0, 1, 2, and then we're gonna combine like 4 plus 5 is 9, 9 plus 2 is 11. And then here we go, the 4, 5 plus 0 is 9. And then since we don't have any city on the right side of the last index, so 5 plus 0 is 5. That is where the optimate comes in. And then this is not the last item yet. So what we want to do, we want to have another variables given in our question, which is a k. So k means like 2 power station for constant that we can distribute in each city or in one city, whatever is most feasible. And then, according to the given question, we need to spread the power station on the city that has a less power station, and we need to maximize it. So we have a lot of option to do in here. How can we do it? What we can do is we can spread our station in index 0, index 1, or index 2, or whatever we would like to. But the requirement is we can only have a 2 extra power station that we can distribute of. So let's say if we want to add the 2 station to the city 0, so which will be the here. Let's go, we distribute in here. So 3, 1 plus 2 is a 3, and then we need to recalculate our values again. So in that case, after we distribute the 2 power station to the first city, and then this will become the 5. And then this will become the 4 plus 2 is 6, 6 plus 3 is 9, and then 4 plus 2 is 6, 6 plus 5 is 11. Wait, 4 plus 2 is 9, 10, and 11. And then we add in here again. 4 plus 5 is 9, 0 is 9. So according to that, so we got like 5, 9, 11, 5. But in here, we just need to return the maximum. So in here, what we need to consider is how do we do it? So since we have 3, 7, 9, and 5. So the smallest we get city if first city with a power station of 3, and then if we trying to add the 2 station at the city of 0, so what it will be is it will become like 3, 2, 4, 5, 0. Then we will try to calculate again. So that will be the 5, 9, 11, 5, and then the minimum power is 5. It's good, but let's test the other option also. How about we put our power station in the second city? Okay, let's keep it as here. So the second city, if we will put it, is will be become 4, since k is 2. So in that case, we're gonna need to regenerate the values again. So it will be the 4 plus 1 is 5, 1 plus 4 plus 4 plus 1 is also 9, and then 4 plus 4 plus 5 is 8 plus 5 is 13, and then 4 and 5 is 9 and 5. So in that case, it's the same city. Why we have to choose the city 1? Since if we put the 2 power station on the very first city, we don't have a usage on the left side since there is no other city on the left of the index 0 city. That is the reason why we choose to put the 2 power station on the first index series, which will make us to spread the power according to the question. So this is to spread the power. Then at the end, if we find the minimums in here is also the 5. That's why the reason in here, the answer is the 5. So according to the estimate, so they are using the 14450, so which is the values in here, and then 591395 is 591395 is written here. So that is one example. But if we run through or dry run to the second example, which is very straightforward, since we have 4 city, each city have a 4 power station, but that power station cannot be spread through the neighbor city. That means everything's a 0. Even though we're trying to put any extra power station to the each city, that doesn't make sense since our minimum base is 4. That's why the output result is 4. So let's start write the code. Let's same as the previous or the problem. We don't want to count through the station again and again. That's why we will use it. And then what I'm going to need is I'm going to create the array, something like a greedy algorithm, which need the extra index. Let's call prefix index, and then I'm gonna create the array repeating the 0 with the count of n plus 1. And then what I'm going to do is I'm gonna update my prefix, which is using the 0 to our station counts. So since we have a 0 true, as according to the example, there will be the 0 to 4. So that's why it's a 0 true less than the station counts. And then how I'm going to do is I'm gonna update the I plus 1 since we don't want to use prefix artifacts as a remaining 0. And then I'm gonna update like prefix of I plus station of I. So we're just going to generate the value like this. Next step, we're gonna need the power array. Let's call it power, and then repeating same as the 0, and then count will be the n. Since this is just to calculate the power, something like this array, we don't need the extra buffer. And then I'm gonna go through like a power the same as the previous before, but for the power I need to go through left and right. So for left and right, let's call it like I in 0 dot dot less than n again, since we're gonna iterate through. So we need the left value, which will be the mass of 0 I minus r. This will be the left. I also need the right value, which is a minimum of n and I plus r plus 1, which is I is the index 0, r is artifacts that's given here, which is r is a 1, and then plus 1 is we're gonna conclude that both sides. Yeah, so that's how we calculate the left and right. So after we got the left and right, should be the left, not left. And then how we can do is we're gonna update the power index by using the prefix of right minus prefix of left. That's how we calculate the power. And then we're gonna use maybe we can use a binary search approach. Let's go like low will be the power of minimum. Let's do it as a force wrap since we don't have an option in here. And then low height will be the power of max. And then plus k, since we want to add the extra power station to the mass of the height. And then we need the initial answer will be the low. So what do we do? How we do is while we have a low less than or equal to height, what we're gonna do is we're gonna calculate the minimum with the mid, which is low plus height divided by 2. And then I think in here we need a one function which will help us to calculate. Let's create the one function here. Let's call like this function can, and then if the function can calculate the verify that it is a valid power station to add or not. Let's call it add. That will be the array. We need the repeating of 0, same as the previous. Let's call like n plus 1. And then we need the current, which is a 0. And then we need the remaining, which will be the k. After that, I'm gonna iterate through I through 0 to the n. After that, I'm gonna iterate and increment the current with the addition of I. So we need to understand the total in here, which will be the power of I plus current. So that is calculating the value. So power is here, and then current is we are iterating through the index. So power plus index will be create the total for us, and then if total is less than, what should we call it, 8, which will be the parameters in here. If less than, we're gonna calculate how much power station we need. Let's detect the x minus total, and then we're gonna decrement the needs from the remaining. And if the remaining begin 0, because there could be the chance, it's mentioned that the denotes is absolute values. That means we don't want minus in here. So if less than minus, that already return the false in here. If not, we can increment the current with the need, and then let's calculate the position here. So minimum will be the n minus 1 and I plus r. So which is we calculating the array, which is the position index of minimum index for the array, and then index plus our artifacts, which is extra area that we can gather from the each city. And then according to that, if what we can check is our position plus our coverage is less than n, we need to plus 1 since this is a position in here. What we can do is we can update our addition array with using the same index 1. We're gonna decrement the need in here. So if everything went well, we return the true. So in here, if can with the mid, what we're gonna do, we're gonna update the answer to the mid, and then low will be the mid plus 1 since this is a binary tree, and then if the not, the height will be again mid minus 1, which will lower down the answer for us, and we just return the answer. Okay, what did I do wrong? In the line mods 5. Oh, I missed the one in here. Let's run through it. Okay. Oh, wait, we have an extra dot in here. Oh, why like that? Okay. Oh my god. Just submit it. What did I do wrong? Line number 27, which we are going to update the remaining value. Wait, we're going to, oh, forgot to return the boolean here. Sorry guys, it's a Fridays and I'm going a lot of make mistake. I think it's beat 100% of the problem. For the time complexity, I think it will be the O of n log n since it's using the binary search. For the space complexity, it will be O of n since we only create an array that is the same size as the input station. Alright, that's all for this, and thank you and see you in the next video.